Okay, we're about to create an ARM program. So this topic is all about creating the main format of the assembly where you can put your code inside. And also we're going to use a subroutine for about the brain and the hand interfaces. Also uh, about the data type, uh, creating data. Here we go. We start the program, placing access text in there. After that, text is all the what the program code needed for the instructions. Okay. This is a our main void main code block. Yeah, but at this time we can do like we can write start at the void main in C or C++. So it goes like this, and then we make it red. And above is like we declare globally. We declare globally. Try to make this like how about this start? Okay, this is declare global. About this one, or just like that. Yeah. Okay. Here we go. So this is our global main block of code, and we ended up here as I recall. This is another call for to close the program by moving into its accumulator. What you call that? Accumulator. So the accumulator is our result location register. Okay. So replace something like a number, a signature number, to call for an exit, and we do ISR here. There we go. My hands seem faster than the keyboard. So that's the EOF of the C. That's the EOF of the main. I'm so pretty fast. And then we're going to save the stack. We push the stack to the frame pointer to the stack pointer, and also the return for the callee, the link, like let's say we push by storing pair this register and the other register, something like and the stack pointer, and then we create a 16-byte foremost. Firstly, that one, like that. we create the storage for this to register the step. That's 8 bytes, 8 bytes, that creates 16 bytes together here. So we store them here, we save, we push them on the stack. Let's say after we before the IS are here to exit the program, we must also push back or to clear the stuff, doing a reloading the pairs of the same one into our SP from our SP. Yeah, it's from our SP register. So we move back is 16 byte storage from this one, from that register, and the stack pointer. And we might also move a word into a register XO, or the same as this is an integer, because we're moving just 3-digit numbers, so we can use word boundary alignment for an integer. Yeah, let's say just 66, or let's try the 69. Yeah, or something like this. Better. These are for the it's all about doing this code in your terminal. That one. It will burst up EVP. Get W this time. This is a success message. Yeah. And then from here is where all you place all your code. Codes. I'm going to, let's say you're going to call your hands. So this is your brain, from starting from here down at the exit. This is your exit signature. So down here and right up here is where all the mind work, your brain or the robot or the processor. So let's say the processor want to call the branch to the level a head thought to a thought. We're going to think, or like a concept, con about the hand. We're going to move the hand. So let's say going to move the hand here, and then we're going to implement that from the synapse of your brain. I would formulate the synapse and the nodes and your spinal cord will cooperate and to the other part of your organ. So let's say it is your end. Okay, like that. Let's say it's your end. Now we can declare it global. Global, that's our hand. We go tab space. Is around. Is the form is interface, and it ends here. EF. Okay. Let's see. What is this? Let's say we just we're going to use the support of the register in your hand. Like say it's starting from X9 to X15, you can use any numbers. So let's say you're going to say something for a gesture of 2 to your fingers. That's the end. So we're going to also create the thought, or like the gesture thought. So we're going to create the data for such a concept. This is your data, and we can declare it global if you like, or just an F, or something like a gesture data. Alright, that gesture data is just an integer. So integer means word, and that equates to number 2, or something like 3. Okay, and that's it. So that's it means integer int gesture equals 3. Let me put it this way. And gesture is equals to 3. It goes like that. Try to do this thing. Gesture. Yeah. You can say exercise gesture is equals to align to 4 bytes, but we don't need to say it because we are not a compiler. Okay. Move back to the hand subroutine, and this is subroutine. Your head is going to call this the arm. The cortex is going to call this just a subroutine. Yeah, this is your void main. This is a subroutine is a function. See, my hand's so fast. That's why I can't type out the C. Okay, we have to firstly the subroutine, we're going to call such a gesture concept, which is data in the somewhere in the memory. So we can do this by getting the address, placing them in somewhere like X10. Can use X9, X10 up to X15 scratch memories registers. Using this. So this is X register is a part of some also a memory, but faster than the DDR. So that gesture, we can call the address of that gesture in the memory, which is gesture data. The gesture data. Can call that. We can somewhat load into the registry, like x10 or x11. So that gesture data is already contained here. We're going to load such the actual meaning, the actual concept of what's inside of that memory. So we can say x11, but the data is only words, so we can say word like w because it's just an integer. X is for 64-bit. This one is for 32-bit data. And then we can move something like on the x9, a number in the x9, and then we can create an intelligent finger, like adding the x9 to double the count of x9. This both register, you can have both register, and then you can just place the register in the somewhere like x12. Are we okay? Let's say add this at the W9. Yeah, that one goes there. So load this here, and we add this, and then we place another to another register like W12. There we go. So we just double this number here, then that is a number 2, or this one. Yeah, about we put the 3 in W9, and what's inside W11, we're going to add them. What's inside in our pre-thinking, and gesture data, and then our intelligent fingers will do like this. We'll add something here, which is part of his registry. It's like doing arpeggio. It's like a muscle memory. Okay, that's it. And then that gesture data is like a tree, and then it's just like doubling using many registers. I think this is not like cleaning the overhead stack of this cortex. So you can use something like this without further instruction. You can use another average child without clearing something there, like cleaning, putting WZR into W9 and moving to W9, but right this time just double child without using W9. Don't need to overuse W9. So okay, that's it. And then we can see the load. This is the return instruction, but we can formats we can say I think we can store. Yeah, we store it into the extent. So extent is where the gesture data reside. That's the address of such somewhere in our uncorrupted memory. That gesture data here is our pre-thinking It's a concept, whether it's a memory in the answer, memory in the brain, somewhere there. It looks like that. It's one. It's like, is there something the W12 because we added here in your super dexterous finger, ambidextrous finger, the W12 of your eyes and nose. Then you place the finger and then you add it up inside and you put it somewhere inside your pre-thinking, and we can dissect it inside the GDB later. So that's it. We're closing the program by putting something, the exit signature, and then the ABB success message, and then the ISR here. So exit is it's like accumulator this time. If you're going to debug this, it's better to place something an opcode here. There's no op and something at the before or after the moving back the stack. So that's it. And then we control X and save. Yeah, here's the remain. There you go. That's it, and then we compile our main example using that one from Travails and MIT Berkeley genius, the one who do the stunt doing the open source. So that's our main. We're going to assemble the file and output for an object, and we're going to place another parameter. The fifth parameter will be the debugging information. Okay, and then we link the object into Bruggy. Okay, into a Bruggy. Take the object. Undefined symbol hand. So we have to move back to our main exercise. Undefined symbol hand. Access global hand. We forget the symbol here. It must synchronize with our declared subroutine. Okay. Okay, let's try this. If it's non-saggy, sag fault, Bruggy, come here.